When I was at school, I always wondered why the second derivative needs to be negative if we want to identify a maximum of a function by setting the first derivative equal to 0. But actually it's quite intuitive. So here there is a nonlinear function that is sketched, which increases first and then it decreases. So clearly it has a maximum here. Now, how does this maximum relate to the second derivative? We take the first derivative, which is in this case 3 minus 2x from here, the 5 drops out. And then we take the second derivative, which is minus 2, so it's always negative. We already know, either from school or from the past video, that we identify the extreme point by setting the first derivative equal to 0. So then we are here. Now, why do we know that this is a maximum if the second derivative is negative? What this means is that at any point along the curve, the slope will always decrease. So the slope starts out with a high value here, and then the value decreases and decreases further in this area. And the implication of this is that if we identify a point at which the function attains a maximum, then it doesn't matter in which direction we move, the function value would always go down. So we would always move in the negative direction, basically. And that implies that we have identified a maximum point, because irrespective in which direction we go, we will always move down. Again, this kind of argument holds for a minimum, just that in this case, the second derivative needs to be positive. We need to move up in each direction in which we go if we identify a minimum by setting the first derivative equal to 0.